Welcome to How to Become an AI Engineer, a roadmap to success. I'm thrilled to guide you through this exciting journey into the world of artificial intelligence engineering, a field that is not only transforming industries, but also redefining how we live, work, and interact with technology. Let's start with a simple question. What does it take to become an AI engineer? For many, the journey can feel overwhelming, filled with buzzwords, rapidly evolving tools, and an ever changing skill set. But today, I'll simplify this path and give you a clear, structured roadmap that can take you from beginner to proficient AI professional. Whether you're just starting out, pivoting from another tech field, or upskilling for a more advanced role, this roadmap is designed to be flexible and practical. It will help you build a solid foundation in core concepts, grow your technical skills through hands on projects, and ultimately position yourself for success in the AI ecosystem. First, let's talk about why AI engineering matters today. From chatbots to self driving cars, from personalized recommendations to fraud detection, AI powers it all. It's one of the most in demand and future proof career paths. Companies across every industry healthcare, finance, retail, education, and more are integrating AI into their operations. And they need skilled professionals who not only understand the theory, but can also apply AI in real world scenarios. So, what will this roadmap cover? We'll begin by breaking down the core skills you need: programming in Python, data manipulation, machine learning algorithms, neural networks, and model deployment. Next, we'll explore education paths, from self learning and online boot camps to formal degrees and certifications. You'll learn what matters and what doesn't, depending on your goals. Finally, I'll share strategies to build your portfolio, contribute to open source AI projects, and land interviews for AI engineering roles. Remember, the most important ingredient in this journey is consistency. You don't have to master everything overnight. This roadmap is about progress, not perfection. With the right guidance, dedication, and project based learning, you'll start to see yourself not just as a student of AI, but as a creator of intelligent systems. So, are you ready to unlock your potential and shape the future with AI? Let's dive in. Now that you've seen what this journey is about, let's zoom out and take a look at the broader AI landscape, because understanding where you might fit in is just as important as learning the technical skills themselves. The field of artificial intelligence is vast, diverse, and rapidly evolving. It offers a wide range of career paths, each with its own focus, required skill set, and contribution to the AI ecosystem. On this slide, you'll see four major pillars that represent the most common categories of AI careers: AI research, AI development, AI implementation, and AI operations. Let's start with AI research. This is the cutting edge of the field. If you're passionate about exploring the unknown, pushing theoretical boundaries, and inventing new algorithms or learning methods, this could be your path. AI researchers typically work in academic institutions, R&D departments of big tech firms, or specialized AI labs. They contribute to breakthroughs like transformer models, reinforcement learning advancements, or new approaches to ethical AI. If you're aiming for this track, expect to dive deep into math, statistics, and scientific experimentation. Next, we have AI development. This is where theory meets practice. AI developers take existing models, frameworks, and algorithms and apply them to build real world products like recommendation engines, chatbots, fraud detection systems, or image recognition tools. You'll work with tools like TensorFlow, PyTorch, OpenCV, and Hugging Face libraries. This path is ideal for software engineers who want to specialize in building intelligent systems that solve user centric problems. Then comes AI implementation. Think of this role as the bridge between technical systems and business needs. AI implementation specialists focus on integrating AI into real business or industrial environments, helping organizations deploy, test, and validate AI systems. You might find yourself customizing models for specific use cases, working closely with domain experts, or managing data pipelines. This is a great track for those with a blend of technical skill and business acumen. And finally, we have AI operations, sometimes referred to as MLOps. This area is all about ensuring that AI systems run smoothly at scale. AI operations professionals manage infrastructure, monitor model performance, retrain models when needed, and ensure compliance with data governance policies. If you enjoy DevOps, systems engineering, or scaling technology, this is a critical and growing niche. What's important to understand is that there's no one size fits all career in AI. You can start in one area and transition to another. For example, you might begin as a developer and gradually specialize in ML ops, or you might move from business intelligence into implementation. The key is to be aware of the different roles and pick the one that aligns with your strengths and interests. Now let's talk about how to build the right educational foundation for a career in AI. One of the most empowering things about entering the AI field today is that there isn't just one way in. Whether you're coming from a formal academic background or learning independently, there are clear and credible paths to becoming an AI engineer. This slide presents three major tiers of educational pathways: self learning, industry certifications, and advanced degrees. Think of this like a pyramid. You can start from the base and build your way up depending on your goals, time, and resources. Let's begin at the base: self learning. This is where most aspiring AI professionals start. And the good news, you don't need a formal degree to get going. There are a wide variety of high quality resources available today, many of them free or low cost. You can start with MOOCs, massive open online courses, offered by platforms like Coursera, edX, Udacity, and others. You'll find excellent beginner to advanced courses in Python, machine learning, deep learning, and natural language processing. There are also boot camps and tutorials which offer more hands-on, project-based learning. These are great for building your portfolio as you learn. And don't underestimate the power of open courseware from top institutions like MIT and Stanford, which allow you to access actual lecture content from world-class AI researchers. Next up is the middle layer: industry certifications. These can help validate your skills to employers, especially if you're coming from a non traditional background. Certifications from AWS, Microsoft Azure, and Google Cloud, such as AI Engineer Associate or Machine Learning Specialist, are increasingly recognized in hiring processes. They often include training modules and hands on labs that ensure you can build, deploy, and scale AI solutions on cloud platforms. These certifications are especially useful for roles in AI implementation and AI operations, where cloud infrastructure and model deployment skills are critical. They also help bridge the gap between theoretical knowledge and practical application. Finally, at the top of the pyramid, we have advanced degrees. If your goal is to go into AI research, contribute to novel algorithm development, or work in high level data science teams, pursuing a master's or PhD in fields like artificial intelligence, machine learning, computer science, or data science can open doors. These degrees provide a strong foundation in mathematics, statistics, and research methodology. However, keep in mind, a degree is not a requirement to succeed in AI. It's just one of the available options. Many successful AI engineers today are self-taught or transitioned from adjacent fields like software engineering or statistics through a combination of self-study and real-world project experience. The takeaway here is simple: choose the path that aligns with your background, resources, and end goals. No matter which route you take, what matters most is your ability to learn continuously and apply that knowledge through projects and collaboration. Now that we've explored your learning paths, let's dive into the essential technical skills every aspiring AI engineer must master. These are the foundational tools and technologies that enable you to build, deploy, and scale intelligent systems. Let's start with the most fundamental one: Python. If there's one programming language to prioritize for AI, it's Python. It's simple, readable, and has a massive ecosystem of libraries tailored specifically for AI and machine learning, like TensorFlow, PyTorch, scikit-learn, Hugging Face transformers, and many more. Python lets you prototype ideas quickly and build models efficiently. Whether you're training a neural network or building an end-to-end machine learning pipeline, Python is the go-to language for AI development. Next is data management. Why is this critical? Because AI is only as good as the data it learns from. You need to know how to collect, clean, store, and access large data sets. This means being fluent in SQL for structured data and NoSQL for unstructured formats like documents or JSON. You should also be comfortable working with data processing frameworks such as Pandas, NumPy, and even Apache Spark for big data. Understanding how to handle data is foundational for preparing training sets, running analytics, and feeding models accurately. Moving on to version control. As an AI engineer, especially when working on teams or collaborating on research, using tools like Git is non negotiable. Version control lets you track changes, revert to earlier states, and collaborate without chaos. It also helps maintain reproducibility, an important factor in AI projects. Platforms like GitHub and GitLab are the standard in the industry, and you'll often use them to share notebooks, manage branches, and document your experiments. The final core skill area here is cloud platforms. As your AI models and datasets grow, you'll need scalable infrastructure to support training and deployment. That's where cloud platforms like AWS, Google Cloud, and Microsoft Azure come in. They offer specialized services for machine learning, such as Amazon SageMaker, Google Vertex AI, and Azure ML. You'll be able to spin up GPU-powered instances, automate model pipelines, and deploy APIs at scale, even if you're working locally for now. Gaining familiarity with these platforms prepares you for production-level AI deployment. Together, these four pillars, Python, data management, version control, and cloud platforms, form the core toolkit of a modern AI engineer. You don't need to master all of them on day one, but you should aim to build strong proficiency in each over time. Now that you've seen the essential tools, let's shift focus to the core concepts that power all intelligent systems in artificial intelligence. If the tools are your hands-on instruments, these concepts are your mental framework. They define what AI can do, how it learns, and how it behaves in real-world environments. We'll explore four key areas: machine learning, deep learning, computer vision, and natural language processing. Together, these form the backbone of modern AI systems. Let's begin with machine learning, or ML. This is the foundational concept that drives most AI systems today. At its core, machine learning is about teaching computers to learn from data instead of being explicitly programmed. There are three major types: supervised learning, where the model learns from labeled examples, like classifying emails as spam or not spam; unsupervised learning, where the model uncovers patterns in unlabeled data, like customer segmentation; and reinforcement learning, where agents learn by interacting with environments and receiving rewards. Think of a robot learning to walk, or an AI playing chess. Understanding ML gives you the flexibility to work across domains, from finance to healthcare to robotics. Next, we have deep learning, a subset of machine learning that uses artificial neural networks to simulate how the human brain processes information. Deep learning has revolutionized AI in the last decade. You'll work with convolutional neural networks, CNNs, for image data, recurrent neural networks, RNNs, for sequence data, and most recently, transformer models like BERT, GPT, and Llama for language and multimodal tasks. Deep learning powers systems like ChatGPT, self-driving cars, and facial recognition tools. It's computationally intensive, but incredibly powerful. Now let's talk about computer vision. This field focuses on enabling machines to interpret and make decisions based on visual input, images, or videos. Common tasks include image recognition, identifying objects in an image; object detection, locating and labeling multiple objects; facial recognition, gesture tracking, and even medical imaging diagnostics fall under this umbrella. Computer vision applications are used in retail, autonomous driving, security, and manufacturing, making this a highly employable subdomain of AI. Finally, we have natural language processing, or NLP. This is the science of enabling machines to understand and generate human language. NLP covers tasks like text analytics, extracting insights from text data, sentiment analysis, determining emotional tone, machine translation, converting one language to another. Language generation, as seen in chatbots and large language models. With the rise of AI assistants and content generation tools, NLP is one of the hottest areas in AI right now. Together, these four areas, ML, DL, CV, and NLP, equip you to tackle a wide range of challenges. You don't need to master all of them at once. Instead, explore each area, build projects, and then choose a specialization that aligns with your goals and interests. Now let's talk about one of the most important aspects of launching your career as an AI engineer, building a portfolio. In AI, what truly sets you apart isn't just your education or your resume. It's your ability to demonstrate your skills through projects. A strong portfolio shows that you can take what you've learned and apply it in creative, practical, and measurable ways. Whether you're applying for your first internship or a full-time engineering role, your portfolio is your proof of capability. This slide outlines 3 levels of project building that you can use to progressively showcase your expertise: beginner, intermediate, and advanced projects. Let's start with beginner projects. At this stage, your goal is to become comfortable with AI tools and understand how data flows through a basic machine learning pipeline. These projects are usually simple classification or regression tasks. For example, a spam classifier using naive Bayes, a Titanic survival predictor using logistic regression, a house price prediction model using linear regression. The emphasis here is on learning the foundational workflow, cleaning data, selecting features, training models, and evaluating performance. These projects demonstrate your understanding of supervised learning and your ability to work with datasets using tools like Pandas, scikit-learn, and Matplotlib. Next, we have intermediate projects. These are more sophisticated and show that you're capable of building functional applications using AI. Examples include chatbots powered by NLP tools like Spacey or Hugging Face Transformers, movie recommendation systems using collaborative filtering, image classifiers trained on datasets like CIFAR10 or MNIST using TensorFlow or PyTorch. At this level, you'll need to think about user input, model performance, and deploying models in simple interfaces, such as using Streamlit or Gradio. These projects help build confidence in your ability to solve practical problems and work with more complex architectures. Finally, there are advanced projects. These are what truly make your portfolio stand out. These are end-to-end AI solutions that simulate real-world workflows. They involve everything from data ingestion and pre-processing to model deployment and monitoring. Some great examples include an AI-powered document summarizer with a web interface, a multi-label sentiment analyzer trained on custom datasets, a production-grade fraud detection system using streaming data pipelines, an agentic AI assistant that combines multiple tools and APIs to perform complex tasks. These types of projects reflect your readiness for industry. They also provide excellent talking points during interviews, especially when you can explain the trade-offs, optimizations, and debugging processes involved. No matter your experience level, the key is to start small and build iteratively. Publish your code on GitHub, document your process clearly, and host project demos if possible. Recruiters and hiring managers want to see evidence that you can learn, solve problems, and ship working solutions. Now that we've covered how to build skills and create a portfolio, let's talk about something just as important: real-world experience. No matter how much you study or how many tutorials you complete, nothing compares to applying your knowledge in live, collaborative environments. This slide highlights 4 impactful ways you can gain real-world experience in AI: internships, open source contributions, hackathons, and research collaborations. Let's begin with internships. These are perhaps the most direct path to gaining industry experience. Internships give you the opportunity to work on real projects at tech companies, AI startups, or research labs. You'll get exposure to production-level code bases, agile team workflows, and mentorship from experienced engineers or data scientists, Just as importantly, internships help you build valuable connections that can lead to full time roles or collaborations in the future. Even short term internships can make a big difference in validating your practical skills. Next, we have open source contributions. This is one of the best ways to build your reputation in the AI community. By contributing to well known libraries like TensorFlow, PyTorch, Scikit-learn, or Hugging Face Transformers, you gain hands on experience with code that's used by millions. You also learn how to write maintainable code, submit pull requests, and respond to code reviews. These are the same skills used in professional environments. Plus, having your name listed as a contributor on a popular repo looks great on your resume and GitHub profile. Then there's hackathons. These are high energy, fast paced events where you form a team, come up with an idea, and build a working solution, often in just 24 to 48 hours. Hackathons are fantastic for testing your ability to build under pressure, collaborate with peers, and pitch ideas. You'll also gain experience in project scoping, feature prioritization, and presentation, key skills in real world product development. Many companies use hackathons as a way to identify promising talent, so it's also a great networking opportunity. Lastly, we have research collaborations. If you're academically inclined or interested in publishing, consider working with research labs, either at your university or through external academic institutions. Collaborating on cutting edge projects not only deepens your understanding of AI theory, but also allows you to contribute to scientific knowledge. Publishing a paper or co authoring a study can establish your credibility in the field and open doors to PhD programs, fellowships, or research oriented roles at tech firms. Each of these experiences, internships, open source, hackathons, and research, provides a unique lens into the professional AI world. You don't have to do them all, but engaging in even one or two can significantly accelerate your growth and improve your employability. Congratulations! By this point in the roadmap, you've learned the core skills, built a strong portfolio, and gained real world experience. Now, it's time to transition into the job market and land your first role as an AI engineer. The job search process can feel daunting, but with a structured strategy, you can greatly improve your chances of success. This slide outlines 4 actionable pillars for launching your AI job hunt: target companies, tailor applications, technical interviews, and negotiation. Let's start with target companies. One of the biggest mistakes candidates make is applying broadly without direction. Instead, take time to research companies that are actively investing in AI across various industries. This could be tech giants like Google or Meta, startups building AI native products, or even traditional companies in healthcare, finance, and logistics that are building internal AI teams. Use platforms like LinkedIn, Crunchbase, and industry reports to identify organizations with AI initiatives. Narrow your list down to companies where your interests and skills align with their products or mission. Next, focus on tailoring your applications. Recruiters can spot a generic resume instantly, and it usually goes to the bottom of the pile. Instead, customize each resume and cover letter to highlight relevant projects, tools, and results. If the role emphasizes NLP, feature your chatbot and language model projects. If the job involves computer vision, showcase your image classification work. Be specific, use keywords from the job posting, and focus on quantifiable impact. A strong, tailored resume increases your interview chances dramatically. Now let's talk about technical interviews, a crucial part of the process. AI roles typically involve multiple rounds of interviews, including algorithm and data structure questions, system design challenges, and possibly even model optimization tasks. Prepare thoroughly using platforms like LeetCode, Interviewing.io, and Exercism. Review concepts in machine learning, Python programming, and system design for data pipelines or model deployment. If you're applying for research-oriented roles, you might also be asked about the math and theory behind models. One useful tip: practice explaining your portfolio projects out loud. Employers want to hear how you approached a problem, what challenges you faced, and how you made decisions. Clear communication is just as important as technical skill. Lastly, don't forget about negotiation. Once you receive an offer, take time to understand the full compensation package, including salary, bonuses, equity, and benefits. Use sites like Levels.fyi, Glassdoor, and Payscale to benchmark offers. If you're new to negotiation, consider talking to mentors or using resources like Candor or Blind. Remember, the first offer is rarely the best offer. In summary, a successful job search is about strategy, alignment, and preparation. Know where you want to work, show them why you're a fit, and be ready to communicate your value clearly and confidently. You've just completed a comprehensive journey through the essential building blocks of an AI engineering career, from foundational skills and technical tools to portfolio development, real world experience, and job search strategies. Now it's time to make it personal. This final step is about taking everything you've learned and translating it into your own custom roadmap for success. Let's walk through how to do that, starting with three core actions: assess your starting point, set specific goals, and execute consistently. First, begin by assessing your starting point. Take an honest inventory of where you are right now. What are your strengths? Maybe you already know Python or have some experience with data analysis. Great. Now, what are your gaps? Maybe you're new to cloud platforms or haven't yet built a complete machine learning project. That's okay. This step is about clarity, not judgment. Think about your background, your interests, and your transferable skills. Whether you're transitioning from another tech field or just getting started, this step will help you plan realistically. Next, it's time to set specific, actionable goals. Avoid vague ambitions like, I want to work in AI someday. Instead, define milestones with clear timeframes. For example, by the end of this month, I'll complete a beginner ML course and build my first classification model. Or, in the next 3 months, I'll contribute to an open source NLP project on GitHub. Break down your long term aspirations, whether it's landing a role, publishing research, or launching a product, into bite sized monthly or even weekly goals. This creates momentum and keeps you focused. Finally, and most importantly, execute consistently. The biggest difference between people who dream about working in AI and those who actually do it is daily action. Even 30 minutes a day adds up. Commit to a schedule that works for you. Track your progress. Reflect on what's working and adjust as needed. Join communities that keep you accountable, whether it's a Discord group, a local study circle, or a LinkedIn learning cohort. Surrounding yourself with other learners and mentors will help you stay motivated and inspired. Remember, this isn't a race. Everyone's journey in AI looks a little different. What matters most is that you keep moving forward, step by step, project by project, milestone by milestone. You now have everything you need to begin your AI career with confidence: the roadmap, the resources, and the mindset. Whether you're a student, a working professional, or a curious self learner, the field of AI is wide open, and it needs people like you who are willing to learn, build, and shape the future. So take that first step today. Pick your first milestone, put it on your calendar, and begin. Thank you for joining me on this journey toward becoming an AI engineer.